Okay, so today's lecture number 2 of COMP4300, and today we're jumping right into the assignment. So the way that this is going to work is I'm going to first show you like the assignment. You download the zip file, which is not out yet, but it will be this evening. I'll show you the structure of that assignment. So once you know the first one, just like the people who've done another course with me, once you know how the first one works, all the rest are going to be very similar to that. And so I'll show you all of that and go through everything you need to do for the assignment, show a demo of it working, go through the skeleton code that I'm giving you and how you'll modify and submit that to D2L. And then after all of that, because that's the most important stuff, after that I'll go through the setup of how you actually set up the development environment, because I want to make sure that you know how the assignment works most of all. And honestly, even if I didn't show you how to set things up, there's a really detailed instruction list that I'm sure you could all get through no problem, but I do want to just show it working to prove that it's all there. So first of all, I just want to make a few differences clear between the operating systems. So I'm going to be, my laptop that I happen to have here is a Mac laptop. And that's because I got it through school. I'm not saying Mac is better than Windows. I use Windows at home for my primary development machine, but I have a Mac here. So while I'm, all year, while I'm showing code and stuff, I'm going to be using VS Code, because Visual Studio for Mac is not great, and it is not what I would recommend for developing in. So if you are using Mac or Linux for developing for this course, I highly recommend VS Code. And then you just type make into any terminal, including the built-in terminal, and it'll compile and run your game. So when I'm showing stuff here, just because of convenience, and so I don't need to run a Windows VM every time I want to show you some code, I will be demonstrating things in Mac, but it should all work in every operating system. Okay, so the first thing you're going to do for your assignment is set it up, but we'll get to the setup at the end of the lecture. I want to get through the assignment itself. So you will get a zip file which contains a number of directories. Those directories will be bin, source. You will not get the solution source. This is just my local Git repository. You'll be getting a Visual Studio folder, a marks file, an environment setup file. So this is the detailed instructions on how to set everything up for every operating system. This lecture.txt, that's just my notes in case I forget what I was doing during the lecture, so you won't get that. You will get a make file. So this make file will work both in Linux and in Mac. And you will get a readme.txt, which is a very detailed set of instructions for exactly what to do for the assignment. So what we'll do is I'll first go over the directory structure, all the files like in detail. Then I'll go over that README file and I'll give a demo of the assignment and explain exactly what you need to do. And yes, it will take about a half an hour or 45 minutes to go through the assignment. Don't be intimidated just because it takes a long time to read all that. Just because it takes a long time to read doesn't mean it takes a long time to do. I just want to give you the most perfectly concise description of the assignment as possible. So I'll just go from top to bottom here. So the first thing you'll get is this bin folder. The bin folder, bin stands for binary. So everything you compile either in Visual Studio or on Mac or on Linux, the make file, it will put all the executables that are compiled into the bin folder. So then you could either double click the exe file in Windows, or you could run it on Mac or Linux and it will run that. You'll also be given a solution executable file. So the solution executable files have been compiled for Mac Silicon. I'm using an M3 here. I think it works on M1, M2, M4 as well. And you'll also be given a Windows x64 solution file. I don't think anyone here is going to be running 32-bit version of Windows. Because there are so many different distros of Linux, I'm not providing a Linux solution file. But so if you want to see what the solution should look like, just refer back to the video for that. I apologize to the Linux users, but I'm not providing like 12 different executables for that. You'll also see in the bin file, there will be this config.txt. That is the configuration file for the assignment, and I'll get into all of the details of that once I've gone through the assignment file. There may be this imgui.ini, and what that does, it's not there by default, but as soon as you run any program that contains an imgui interface, it creates this ini file to just store like where the last position of your UI was on the screen. So that's what that file is. And then there'll be this SFML game executable. That is the Mac and Linux executable name that it produces. And if you're on Windows, you might see some _D, that's the debug version, etc. Also inside the bin directory is this fonts directory. And in order to draw text to the screen using SFML, you actually have to have a font file. So this TTF, that's a true type font, and this tech.ttf, the only reason I have chosen that font is because it's one of the smallest font files that I could find, so I didn't include like larger font files for you. And I also think it's free to use, so don't need to run into any copyright issues. So that's the bin folder. The source folder will contain, in this assignment, just two things. One is an IMGUI folder. So the IMGUI folder contains all of the source and headers and includes for the IMGUI library. I'm just giving that to you because it's a special version that's designed to work with SFML, and it's a little annoying to set up, and so I've just included that. It's just there in the source directory. You don't need to install IMGUI no matter which operating system you're using. Then there is the main.cpp file, and I'll get into that later, but assignment 1 just has a single file, right? So typically when you're developing mid to larger size C++ programs, you will have a bunch of different files. You'll have headers, you'll have CPP files, you might see .hpp files. If you're not familiar with those different types of files and what they are, please watch the Intro to C++ lecture. It goes over all of that. But because assignment 1 is so simple and it's just designed to get you up and running with C++, there's just one main.cpp file, and that's it. And so all of your code will be written in that file. Please do not create any additional files for that assignment. You also may see, if you're on Mac or Linux, some .o files, some .d files, and what that is those are the intermediary build files that C++ produces, and then it links all those together to form the final executable. And if I want to delete all of those files, I can come in here. Here I'm inside the folder, inside my terminal, and if I type make clean, it will clean up all of the intermediary build files and executables that you've produced. So if I come back here to the Visual Studio Code and I go back to the source directory, you can see there's no longer those .o and .d files. I didn't actually mean to have those there at the beginning, but it worked out that I got to demonstrate make clean to you. So that's the source directory. The source solution is just my own thing where I store the solution files. The next is the Visual Studio directory. And this contains several files. Visual Studio for Windows has two types of files. It has solution files and project files. A solution file is basically can have one or more project files inside it. So what we'll have for our assignments for this class is we'll have one solution file and one project file that the solution imports, okay? So when you go in Windows at the end, I'll demonstrate this to you. You'll just double click the SFML game.sln file, that's the solution file, and if you have Visual Studio set up and running with C++, it'll open that, and you should be able to just hit compile, and it will all work. You can ignore that directory if you're not using Windows. Next, I have the marks file. So the marks file just goes through what all the different things in the assignment are worth, and so I really want you guys to be able to basically know your grade before you submit the assignment, right? So these are all the grades here, and it might be possible for one group who did the exact same thing to get plus or minus 1% of another group. You know, it's hard to mark everything exactly the same, but at least this is the guide for both you and the TA to be as consistent as possible with the marking. The coding style here, it's 10% of the first assignment, and I just want to make sure you realize that one of the most important things that you'll find when you go to a job out in the wild is, you know, there's religious wars that have been fought over like bracketing styles and indentation and all this kind of stuff, tabs versus spaces. But the only thing that you should ever really be concerned with is to follow the style that's already there at that company, to not mix all these styles so every time you go look at the code, it doesn't look like a Jackson Pollock painting, right? Like it looks more structured than that. And so we will be using almond style indentation and braces. I use 4 spaces for tabs. You can fight me about it, spaces over tabs all day. And we are not going to be using namespace standard. We are going to be referencing standard : every time we like do cout or vector or whatever. So that's just the way that it is, and you'll just get these little tiny nitpicky marks deducted for not following those. That code style mark will go down to 5% for the rest of the assignments, but I just want to say that up front. That's what's happening. So I'm not going to go in detail the marks. They're all listed there, so you should be able to read that. The environment setup file, I will go through that at the end of the lecture, and that will not be included in the subsequent assignment files because you'll have it all set up. So there's only this one-time time commitment to do that setup, and then all the other assignments that you download, you'll just run them and it should work. The make file here, when you go to compile more and more complex C++ programs, there are all these different type of build systems that are available to help you manage settings, compiler flags, linker flags, all this kind of thing, say where the libraries are, etc. That's where this make file comes in. And so if you're on Windows or Mac, the instructions will tell you how, but you have to have make installed. It usually comes packaged with whatever compiler. And so you just type make. Make will then look at this make file, deduce all of the different settings, and be able to compile your program. So this make file here, for example, if I'm over here and I just type make, then it will compile all the different CPP files into their object files. The first time you type it, it's actually compiling IMGUI. That's why it takes so long. And then what happens is it compiles your main file, it links them all together, and it sticks it in the bin directory. So if I go into the bin directory, now this SFML game executable is here, and that's what I would run. And so this is what you will be given at the beginning. I'll go into the demo of that in a second. But that's how it works. But just because doing all that is quite cumbersome, the way I recommend doing this is you just type make run. So there's a special build target inside the make file, which reads this run text. So if I type make run, it will compile and run the program from the root directory. So that's way easier than having to make, wait for it to finish, and then go into the bin directory and then run the file. I don't know why that's giving me an error every time I close. I just probably forgot something in the solution file. Then if I want to delete everything that I just did, I can type make clean. And remember when I typed make, it compiled every single object file in sequence. If you type make-j, that's the number of jobs, and you give it a number of processors, that will compile that many things in parallel. So that was a lot faster than the other one. It did it 8 times as fast because I gave it 8 processors. So that's the make file. The workflow for that is identical in both Mac and Linux. However, if you want to, Visual Studio has VS Code, not Visual Studio, has a number of different extensions and plugins for make files and C++. You can go absolutely crazy with that if you want to, have a hotkey for doing all that, I don't care. But I'm only going to be officially giving you help with typing make, because that's what I'm giving you. Also, I understand that a bunch of people really like Xcode for Mac. That is fine. If you get that set up, that's all on you. I have never used it. I never will use it. I don't want to use it or help you use it. So if you use it, you're on your own. I am giving you this and telling you it works, and this is how it works, and that's what I would recommend doing. Lastly is the README file, which I will get into that right after I give you the demo. Okay, so that's the file structure. Pretty much every single file structure for all the other assignments will be the same, except that there will be more files in the source directory than just one, and there won't be an environment set up in any of the other ones. So every single assignment lecture, I'll be going over, I don't need to explain the directory structure anymore, I'll just jump right into the code. So let's go over and have a look at the solution, what it looks like. And I think I've already compiled a solution here, I have. Okay. So this is the solution running. You can see here, it's a little bit, let me just turn this one. So I'm just going to do this just for this so there's not as much light reflecting off of it. But here we see we've got a window, and in that window there's a number of shapes bouncing around, and then there is a user interface over here. This user interface, this is the IMGUI user interface. It is incredibly easy to program, and if you want to get rid of it for a little bit, you can just click this and it'll sort of minimize that user interface. So I have a number of shapes bouncing around, and by the time you're finished with the solution, what you'll see is that you're going to have some method of selecting an individual shape. And then when you select an individual shape, for example, here I've selected, let's say the green one or the purple one. So I've selected the purple one. Now let the purple one get back on the screen here. So I've got a little toggle Boolean button here, so a checkbox. I can click it. It will turn on or off the drawing of that shape. I can set the scale of that, so how big is it in comparison to its original size. Its velocities are listed here with these sliders. I can change those. I can also come in here. There is a color picker, so I can change the color of the purple thing, right? It's not purple anymore. I can also change the text that's listed inside the box. So here it says C purple 544. And so that's what you have to do. And also you have to sort of get the bounding box sizes of these circles. And there are also rectangles. So I could select the rectangles if I wanted to. I've given them names C green, that's a green circle, R red, that's a red rectangle. And then you can change the colors and the properties of whatever you have selected. So that's your goal here. The only other thing, let me see if this works. Oh, it does, is that you have to draw the name in the middle of the shape. Okay, so I'll zoom back out now that you've seen that. The name drawing must be in the direct middle of that shape, and that may be the trickiest part of the assignment, but I'm sure you'll figure out how that works. So that is the solution code, or that's the solution demo. You'll be given that for Mac or Windows so you can run it and see what your stuff is going to have to look like. And it doesn't take long to explain that when I give the demo, but the full spec of exactly what I want to give you is going to take a little while to read out. But before I get into that, I also want to run the default of what I have given you. So the code that I give you from the very start looks like this. It's just a single circle, hard-coded with some properties, and you do have the skeleton code for this over here, but it may, or does it actually work, what I've given you? Yeah, so this actually does work, but when I set the text, I have to click the set text button, and then this text is down here. So the text is down here in the bottom left-hand side of the screen, and what you have to do is change it so that text is actually drawn in the center of all the circles. Just a quick thing, because I will probably forget this when I come to the code part of this assignment. Oh yeah, you can also click reset here for debugging. Is that in SFML, things are drawn to the screen in a specific order, right? So for example, if I draw the circle and then I draw the text, then the text will be on top of the circle. It's just like literally painting on an actual canvas. Whatever you draw first may get hidden if the thing you draw second is in front of it. And so by default, there is no way to specify I want this to be on top of this other thing other than to draw it after the other thing. Okay, so just realize that that may be one thing. Someone came to me once and said, why is my text not showing up? And they were sure they were right, but it was because they were drawing the text before they were drawing the shape rather than the other way around. So that's the demo. It's not too complicated, but now let's get into the actual README file, which goes through things in detail. I think this is the biggest that I can reasonably make it, so apologies if it's a bit hard to read, but I'll be reading it out, and you'll also have the video later to go over it. So, 4300 assignment 1. This is the the submission instructions. I'll just read this now, but this will be, the same for all future assignments. So it says, note, you will be required to submit main.cpp and no other files for this assignment. Submission will take place on D2L's assignment 1 Dropbox. Only one student from each group of 2 should submit the assignment. So what you'll do is once you submit your assignment, if you're over here inside, I'll just go to this main.cpp, there will be a comment in your version of the main.cpp which says this is the student, here's your student number, here's your email. If you are working in a group of 2, whoever submits the file, just add the other person's info to that box. Okay, so just say, my partner for this assignment is so-and-so. That way the TA can give marks to both. If you forget to do that, it's not the end of the world. We can, go over it after and adjust the marks, but it's great if you can do that right off the bat. Oh, README, I'll just drag this over here. Working solutions are included with the assignment so that you can see what a correct solution looks like. These executables are stored in the bin directory, are provided for 64-bit Windows and Mac. I just forgot to write that there. Just please only try and submit the main.cpp file. I have had a wild variety of things tried to be submitted over the years, like people saving their source code as PDFs and trying to submit that for some reason. Luckily D2L won't let you do that now. It's only a .cpp file. And you must include the following in a comment at the top of main.cpp. One is both of the students' names, CS usernames, and student numbers. And I'm a very big proponent of partial marks. So if during any assignment you didn't quite get something to work, tell me what you tried, what it was that didn't work. Just be honest. Say, hey, we tried this and this, it didn't really work. You might get some partial marks for having explained what it was that you didn't get working. So for example, on assignment 1, you can say, oh, I got my text almost centered, but I couldn't exactly figure out how to do this particular thing for assignment 1. All right, so I won't have to read that again because that top part will be the same for every assignment. But I will be just going through and reading all of this text to see if we have any errors, but we should be fine. So in this assignment, you will be writing a C++ SFML program which will read descriptions of shapes from a configuration file and then draw those shapes to the screen. Each shape will have a name, position, speed, color, as well as properties unique to each shape type. For example, a rectangle will have a width and a height, and a circle will just have a radius. So the configuration file will be a little bit different for circles and rectangles. For this assignment, the position of a shape refers to its SFML default of the upper left corner of the shape. What do I mean by that? Well, let's go back here and we'll run the solution again. In normal mathematics, I'm sure you've all taken linear algebra, you've all graphed formulas and stuff. So in most of mathematics, whenever you draw a graph, the 0, 0 point is in the bottom left. And then x would increase as you go to the right, and y would increase as you go up. However, in most graphics APIs, including SFML that we'll be using, x is still the same, x increases from left to right, but the y0 is on the top. So 0, 0 of most graphics drawing APIs is in the top left rather than the bottom right. This is not going to make a huge difference for assignment 1, but later when we talk about things like gravity, well, gravity is pulling you down, which is actually an increase in the y value for this one. So in some cases, you will have to worry about that, not so much for assignment 1. But just keep in mind that x is increasing to the right from the top left, and y is increasing going down, right? And by default, and I'll go into more SFML stuff in the next lecture, this is only for the assignment, but by default, if you draw something with like location 500 pixels in the x direction, 400 pixels down, then this will literally just shift over 500 pixels on the screen and 400 pixels down. Later, when we talk about cameras and views, we may have a situation where the window, what it is seeing, and where you are drawing are not a one-to-one correlation anymore, but that's going to be a bit later in the course. I'll just leave that running for now. You are also required to make these shapes bounce off of the sides of the window, which contains them. This means that if a shape's left side hits the left side of the window, its x speed reverses. So all of these shapes are going to be given an initial velocity in x and y, and when you detect that the left-hand side of a shape has gone less than 0, then you're going to simply reverse the velocity so that it in the x direction so that it goes starts going in the opposite direction. If the top of the shape hits the bottom of the window, hits the top of the window, then its y speed reverses. Similarly, if it hits the right side or the bottom side of the window. So this means you constantly have to be checking every frame. Does the left-hand side, is it less than the left-hand side of the window? Does the top hit the top? Does the bottom hit the bottom? Does the right hit the right? And so if it does, you're going to reverse the speed in that direction. And that's as simple as you need to do to be able to make things bounce around the screen. You can assume that all shapes will always be configured to start entirely within the window, and you don't have to worry about what happens if they start outside the window. Each shape's name should be drawn on the exact center of the shape in the given font and color specified in the file. Note, this may be the trickiest part of the assignment. You will not lose many marks if it's not in the exact center. So what I meant here, one thing that can happen is that if it may be a little bit buggy if the shapes started outside the screen, right? So I'm going to guarantee you that for the cases of debugging this program, all of the shapes we give you will be entirely within the bounds of the screen. And also, if you wildly increase the scale of this while it's like right next to the window, it may bug out, because what's happening now is it thinks it's colliding every single frame. That won't happen if the scale didn't do this, but I'm just letting you know this, that we're not going to be worrying about that. So you don't need to worry about this particular edge case of, as it's about to collide, you massively increase the scale and it causes some bugginess. I'm not going to be worrying about that for this assignment. You're also required to implement an IMGUI user interface, which is able to do the following. List all of the shapes and select any one of them to edit their properties. There are a number of different ways you can do that in IMGUI. I've chosen a drop-down menu. Whatever you get to work is fine as long as you can select them. Toggle whether or not the selected shape will be drawn. Change the scale of the shape. Change the X and Y velocity of the shape. Change the color of the shape. And change the name or whatever is being drawn to the shape on the screen. So a lot of the skeleton code for that has been provided to you. However, as we'll see when we open the file, I'm only drawing one hard-coded shape. And so what you're going to have to do is come up with some way to store an arbitrary number of shapes. So maybe you have a vector of circles or a vector of rectangles or a set of whatever, right? So you're going to come up, that's part of just learning C++, is how am I going to read these things in and then store an arbitrary number of either of them into these containers. And just so you know, just because there are 3 circles and 3 rectangles here doesn't mean that that's the only case that you need to get working. So you have to have this working for if there are no shapes, if there are some rectangles but no circles, if there are some circles but no rectangles, etc. So it could be an arbitrary number of either of those. So don't, just hard code 3 variables for 3 circles and 3 rectangles. It has to be able to store an arbitrary number. I think I said this already. Do not worry if rapidly changing the scale parameter causes the shape to go outside the bounds of the rectangle. Assume that it will only be changed to remain within the rectangle. The newly scaled shape should be properly bounced within the new size. So the only thing I really care about the scale is that it does indeed draw the thing bigger, and that the new bigger or smaller thing is bouncing properly with its new shape. A sample configuration file is given for you in config.txt. However, marking will be done with an unseen config file in order to test more completely. That's what I've just talked about. Be sure to add and remove your own shapes to this file to test if they all work correctly. Each line of the configuration file specifies one of the config settings of the assignment program, with the first string in each line being the type of setting, and the rest of the line specifies the details of that setting. Lines in the config file can be in one of the following types, and the lines may appear in any order. So let me just open the config file before I go into this in too much more detail. So the config file is in bin config.txt, and here's what you'll see. Let me just make this a little bit bigger. So what I mean by what I just said was that each line specifies one configuration option, and the first string on each line specifies the type of configuration option that we're about to talk about. So for example, this one says window, and the next 2 lines are the width and height of the window. The next one specifies the font. This is a relative path that will contain no spaces. And then here are the properties of that font. And then there will be some circles and some rectangles. And the assignment text file, which I'm about to read out, goes into the details of what each of these variables means. If you're not sure, again, how to do file reading like this in C++, then the Intro to C++ video, I literally go through an example almost identical to this, where we go through different lines, we check the first line, the first thing, and then if that is this thing, we read in the settings file, etc. One thing that I will be checking on the grading in the marks is that you are using like modern C++ stuff. So like you're actually using IOStream to read from files. You're not using like old style C capital file pointers and all this kind of stuff. You're using more modern C++. And all that is talked about in the Intro to C++ video. So, I gotta make this smaller again. So here is what each of those settings mean. Window WH. This line declares that the SFML window must be constructed with width W and height H, each of which will be integers. Next, we have the font. So it will say font, then these 5 numbers. So F is a string. That is the font file. That's where the file is actually located. The next is S. That is going to be the size. So you'll read in that, you'll store it somewhere, and then you'll set the font size to that. And then we're going to have an RGB color. I'll talk about colors a little bit later, but I'm sure you've all seen RGB colors before, where you have values between 0 and 255 for each of the red, green, and blues. So this is going to be red, green, blue. So for example, if you see a color that's 255, 0, 0, then only the R has a non-zero value, so that will be some shade of red, right? If we combined red and blue, what would we get? Purple, right? So that's how our color space is specified. Then we have the 2 shapes. So rectangle is going to have a bunch of different parameters. Here's what they are. So the first thing, that is going to be the string that is to be drawn on top of that rectangle. That is the name. Then we're going to have X and Y. That is 2 floats. So by default, for all of our positioning in all of our assignments, we are going to have floating point values. And we'll talk about this next week, but SFML has a vector 2F. That is a 2-dimensional floating point vector. And so that will have an X and a Y. So that's what we're scanning in here. Then we'll have an initial speed. So that is the speed that the object will be moving at, measured in pixels per frame. And so every time the screen refreshes, and again, we'll talk about that later, how that all works, it's going to be moving over by SX, and it's going to be moving down by SY. And if SY happens to be negative, then it'll be moving up. And if SX is negative, then it'll be moving to the left. Next, we have the RGB colors. So that is the color of the rectangle. And then we also have the size. And the size of a rectangle is going to be defined by the width and the height. And that's it. And then the circle, everything about the circle up to the width and the height part of the rectangle is going to be identical. So I don't need to talk about these because they've already been discussed. So again, it's the name, the position, the speed, the color. However, instead of having a width and a height, the circle just has a radius, okay? So you may ask, well, if it doesn't have a width and a height, how am I going to know if it's bouncing off of the corners of the screen, right? Because it's really easy if you have a position, a width and a height to know when it's going to bounce. But it turns out that it just so happens that if you draw a rectangle, or I guess a square, around a circle, right, where its sides are 2 times the radius, that's the only places that it could possibly bounce. And so if you just take 2 times the radius to be the width and height of the circle and treat it as a square, that will bounce off the sides perfectly. And so you don't need to worry about that because you can just get that. All right, some assignment hints. So in order to store an arbitrary number of shapes from the configuration file, you must store them in a container. I recommend standard vector. It is a contiguous data structure. It's really efficient. It's just there for you, so why not use it? Consider creating a custom class or a struct which stores all of the properties of a shape that are not stored within the SFShape class itself. Again, next week I'm going to deep dive into like what shapes are, their properties and stuff. But consider making your own little structure that has things like, okay, here's the shape, here's if it's a circle or a rectangle, maybe there's a Boolean there that says which one it is. What's the radius or what's the width and the height of that? What is the speed? What is the string? So you could make a little tiny class or a struct that stores all of those things and then make a vector of those things. But the cool thing about assignment 1 is that as long as it works, I don't care how janky it is. This is your time to like learn how to do this sort of stuff in C++, and there will be no marks taken off for inefficiency or dangerousness or whatever. I just want you to get this working. And please, again, I highly recommend not just throwing this into some LLM to get a suggestion, because like knowing the most optimal thing, you don't really appreciate it until you've tried to do it on your own, right? So really try and, there's no gratification without suffering. If things like, you're not proud of taking a breath because it's so easy to do. Be proud of having done something on your own. So try and come up with a solution to that. A shape will touch the side of the window if its bounding box makes contact with it. Each shape's bounding box can be obtained via... Now, this is the type of thing that you probably would be using like Google or Stack Overflow or AI or the documentation for. Because how would you ever have known that each of the shapes in SFML has a function called getLocalBounds, right? That's not a derivable thing. All the math, all the other stuff is derivable. This is just something that you have to be told. And so shape.getLocalBounds has a .top, .left, .width, and .height. And what you can do is you can take the position of the shape and then the size of its local bounds, and that's how you know where the right-hand side of this shape will be or where the bottom of this shape will be. So play around with that. So there's getLocalBounds, there's also getGlobalBounds, and getGlobalBounds will take into account any scale, translation, etc. that has been applied to the shape. So just play around with both. You could use either getLocalBounds or getGlobalBounds. Local bounds just means, I believe, I could be mistaken, but we'll go over it a bit next week. GetLocalBounds means with respect to its current position, and getGlobalBounds means there's no respect. It's just like where it happens to be. Similarly, an SFTextElements bounding rectangle can also be retrieved via this, which you need to use to center the text properly within the shape, right? So every bit of text, once you construct the text with a font and a given font size and a given amount of text, then that text also has a bounding rectangle. And you can get the size of that with SFText. So what you have to do essentially is position the text so that the center of its bounding rectangle is in the center of the shape. And so that's really the most tricky part of this whole assignment, is just doing that very small amount of mathematics. And please use C++ file reading. Standard input file stream makes it very easy rather than C-style file reading. You will be losing marks for older C-style stuff. All right, so that is the assignment README file. That is what you have to do. And now we can jump into, let me just make sure I am going through this in the right order. Check my notes. Okay, file structure, assignment. Yeah, so the assignment code. Make sure not to click the solution. All right, main.cpp. So here's where you'll be spending most of the time of this assignment inside this file. And let's remind ourselves really quickly of what this actually does. Okay, so A1 student. So this is what the code I'm about to show you does. It has a single circle that starts up in the top left, moves very slowly down across the screen, and has all the IMGUI stuff associated with it. So that's what we are about to look at. All right. One other annoying thing is you're about to see standard print. I was so proud of standard print and showing you modern C++ 23 stuff, because standard print in C++ looks just like almost any other programming language. And in fact, if I go down here really quick, standard print actually uses like Python style formatting. It's like really easy to do. It's a little bit easier than standard cout. But it turns out that standard print does not come standard with new versions of GCC. And so I'm just going to be taking this out like later this evening and updating it. But that's why you see it here and not in your actual assignment file, is because the Linux folks would have to change this if I ended up using standard print. Okay. So here are some includes up at the top of the program. So we're going to be using here, I will be changing this to IOStream. It's a slightly older way of printing stuff out. Memory, fstream. Fstream is the file stream that I'm going to be using to read from the file. Here I'm including SFML graphics.hpp. If we wanted to do something like play sounds, then I would have to include SFML audio.hpp. And I'm also including the IMGUI libraries. So a minimal amount of includes here. But for example, one of the things you're going to have to do is probably include vector. If you want to use the vector in C++, then you have to include it like that. If you wanted to use a map, you would have to include map. If you wanted to use whatever, you have to include it, just like any other programming language. So now we'll go through what I have here for main. I won't be going into all the details of everything because at this point I'm assuming you've watched the intro to C++ video or you have a good working knowledge of C++. So what we're going to do here is we're going to create a new window of size width by height pixels. The top left of the window is going to represent 0, 0, and the bottom right is going to represent width height. You will have to read these from the config file. So I'm hard coding all of this. There's no config reading in the skeleton code that I've given you, but I've just hard coded it here. So the way we're going to do that is to create a new render window. So the SF namespace, that is where all the SFML code is. So I'm going to say SF render window, and inside there, we have this SF video mode, which can take a bunch of different parameters, but all we need to worry about is the width and the height. I want to mention this really quickly, is that one of the main differences between SFML2 and SFML3 is this. In SFML2, a lot of functions took in a separate x and y, like this. But in SFML3, it takes in a single variable, which is the SFML two-dimensional vector of that given size. What you can do as a little shortcut to convert x comma y into this thing is just wrap it in curly braces, and then SFML, well, the compiler will know, oh, what is the data type of these? I'll automatically convert it into that single type, and that's where it is. So that's why this is wrapped in curly braces, because SF video mode actually takes in an SF vector 2u, being two unsigned integers. Okay. Then we are going to be, for this class, we are going to be limiting all of our games to 60 frames per second, because all of our games, the game logic, or the tick rate of the game logic, is going to be tied to the rendering rate. We'll have a really nice lecture about that later in the class, but just realize that the way all of these assignments are going to work is that there's going to be a main loop, and inside that main loop, it's going to do all the game logic, read all of your input, then draw everything to the screen, and then wait the amount of time. So for example, if we're limited to 60 frames per second, that is a maximum, not a minimum. You can never set a minimum frames per second because your code may be wildly complex and take over a second to calculate. You can set a maximum, right? So for example, 60 frames per second is approximately 16 2/3 milliseconds per frame. So if you have 16 milliseconds per frame and your calculations have only taken 1 millisecond, then what this will do automatically under the hood is wait the remainder of the time in that 16 millisecond frame before going to the next frame. So that's what this does. And just to make sure that all of our assignments run at the same speed, we're just setting that to 60. Sorry, all of you high refresh rate gamers out there, but we're limiting it to 60. But if you did set this to 120 frames per second, the difference between this and a modern game is that now all of the shapes will be bouncing around twice as fast because our frame rate is tied to our game logic. Okay? But we're going to just keep it simple for the first few assignments, so we're just setting it to 60. Now, this line of code here sets up the window that we're going to be this is the IMGUI setup of the window. So IMGUI has to know where it is drawing to, and this is the IMGUI way of doing that. So this function, IMGUI SFML init, returns a Boolean. And the Boolean is whether or not it was successful. And you'll see this programming pattern a lot, especially in C and C++, where I try and do something with a function. You'd think that that function would be void, but what it actually does is returns a Boolean or an error code of whether or not it was successful in doing its thing. So because this returns a Boolean, we can check it and say, if not that, meaning, hey, if that was false, then there's some sort of error. And if we can't recover from that error, then we should probably exit. So this says, if I can't set up a window, then exit. Because why would we do anything if we can't set up the window, right? So that's just a little bit of basic error handling. I'm not going to be too picky about error handling in this course. I mainly just want to see the stuff work. Next, in order for IMGUI to work properly, there has to be this clock which records the time between events. You don't need to worry about that. You just have to have it there. What this line of code here does is basically just for our sanity, because if we look back over here, this IMGUI window, you can see kind of how small it is. That's actually double the original size. So IMGUI by default is this like eye-squintingly small font value. So what I've said here is scale all of the UI elements by 2 and scale all of the fonts by 2. So if you're having a hard time and you need to, like if you need to, a bigger font size or bigger whatever, that's where you would set it. But please just keep it to 2 for the actual submission, because that's what we're going with. Here is the only real annoying thing between the communication between SFML and IMGUI. Normally they talk to each other pretty well. However, IMGUI's color space represents R, G, and B as floats between 0 and 1, whereas SFML represents RGB as ints between 0 and 255. So the color picker that we set up in IMGUI has to have 3 floats associated with it between 0 and 1. So that's what's going on. And so by default, this is the G is 1 and the B is 1, meaning the blue and the green are maxed. There's no red, so that's like a teal color. That's why a teal color gets drawn to the screen. Now again, when you get this, you're going to have one of those color pickers for each of the shapes, right? So you'll have to store that somehow. Then let's hard code all of the variables for that single circle that we have to the screen. I'm not reading anything from a file. So we have the radius, the number of segments. The number of segments, do I have that over here? Yeah. So let me reset this circle. There's no such thing as drawing a circle in a computer. Why? Who can give me the mathematical definition of a circle? Anyone? Sure.
Always the exact same distance from the center.
What are?
Oh, the edge.
Sure. How many points are in that edge?
Oh, infinite.
Infinite, right? We can't draw infinite points. And so circles are always approximated by some number of points, and you have to specify that. Here's a circle with 4 sides, right? So in assignment 2, we're going to be abusing this fact to be able to draw octagons or hexagons or whatever by just drawing a circle with a specific number of sides. So that's what that 32 is. 32 is enough that you think it's a circle when you look at it. Circle speed, circle speed X, circle speed Y, whether or not we draw the circle, whether or not we draw the text. Okay, so in SFML, you set up the circle shape with the radius and the number of segments. You give it a position. Then we set up a font. We open the font from File. So now I have that font open. I'll be going over this in more detail. I kind of want to go through this a little faster now. I'm setting up the text, which gets drawn in the bottom of the screen down here, which says sample text. Then we set the position of that text. That's where you will set it to the middle of the shape that's currently being drawn. Here, in order to set up in IMGUI a little thing where I can type in text, we actually have to have an old school C-style character array. So that thing can only hold 255 characters. Again, this is all in the SFML documentation. I'll get into that later. Here's the main loop of the whole program. All right, while the window is open. So if the window ever gets closed, our program exits, right? Because if it's not open, we will exit this loop. Here is the event handling. I'm going to get into this more when I go to the next lecture, but this is essentially saying check to see if there are any events. If there is an event, pass that event through to IMGUI, because IMGUI needs to handle these mouse events as well. Otherwise, if the event is the window was closed, then close the window. Here is how I would detect a if a key is being pressed or a mouse button is being pressed, etc. I'll go into more detail on that in the next lecture. This is just all here for you. We're not actually pressing any keys in this assignment, but it's just there if you want to have a look at it. Then IMGUI needs to be updated so that it can draw all of its things, and then we draw all of its things. So IMGUI, I'll have a big, way more time to talk about this next week, but essentially, if you want a text element on the screen, it's just IMGUI text. If you want a checkbox, just say IMGUI checkbox. And here's where IM means immediate mode. You have probably all done some sort of UI programming in the past with like callback functions or all this sort of weird stuff where I'm going to create a checkbox and then I need to like ask to see what the value of that checkbox is in order to do this other thing. But what this does, the genius of IMGUI, it just says IMGUI checkbox with a title that gets displayed, and then you pass in the pointer to the Boolean where that value should be stored. And so now, when you click that checkbox, it actually sets the value of that Boolean for you. And then later on, when you go to draw that thing, you can just check that Boolean. Similarly, here is a slider float. So a slider float modifies a floating point value. Here's the title of that. It's radius. Look at this. It's a floating point. I can change it here. And all you have to do is give it the pointer to the float that you want to modify, a min value, and a max value. No other programming language, or no other UI library could possibly do this simpler, right? Here is that entire UI. You couldn't even do that quickly in HTML and CSS, right? It's really, really quick and it's really easy to do this UI stuff. And you might say, how do I do events on button clicks? Well, you just say if IMGUI button with the text of the button you want to appear, and then why does it say if button? Because that will be true on the frame that you click it. And so when you click it, this is what happens. That's it. So if this button is clicked, do this stuff. It couldn't possibly be easier. All right, I'll skip the rest of that stuff to go down here. I'm setting the points and the radius of the circle based on the things that I've input from the IMGUI. I set the fill color. Here is where I do that annoying conversion from IMGUI's floats over to SFML's ints. So I just take the float, which is between 0 and 1, multiply it by 255, and then make it an integer. That's basically it. I set the position, and then, hey, first thing I do is I clear the window. So if I didn't clear the window and I recompiled this, it would literally be drawing a circle, and it's almost like, you know, that glitched solitaire, like at the end of solitaire, it keeps drawing all the cards. It would just keep drawing circles without clearing anything. So we have to clear the window. The clearing of the window actually takes a hidden parameter, which is the color that you want the background to be, but by default it's black, so I just left it black. If we draw the window, window.drawCircle, or if I draw the circle. It couldn't be easier, just draw the circle. If I'm drawing the text, draw the text. Couldn't be easier, right? Then IMGUI needs one more final call where IMGUI actually does its rendering to the screen, and by doing the IMGUI rendering at the end, then we're assuring that the IMGUI window is on top of all the other stuff. If I drew IMGUI before drawing the circles, it would be on top of all the circles, or it would be on top of the UI. Then we call window.display, which swaps the buffers, which I won't get into now, but that actually draws everything to the screen. And that's it. That's the skeleton code that you've been given. What you have to do for this assignment is take the config file, read it in, create some structure that stores an arbitrary number of things, and then draw those to the screen. All right, we've got about 20 minutes left, so that's the assignment, basically. The assignment isn't complex because this is where you have to set up all your stuff. You have to get used to C++ a little bit, get used to IMGUI, get used to SFML. So the first assignment is pretty simple in terms of the logic. Question?
I don't know if you've explained this before, but I thought I'd just ask, what is IMGUI and what is SFML, and how is that related to C++? Are they libraries, frameworks?
Yes, they are. So SFML is the graphics library that does the window, the event handling. I talked about that last time. IMGUI just draws that little GUI window. And I have an entire lecture of a tutorial next week, which will go into all of those details. Yeah. But you can absolutely get started on the assignment without that tutorial. I'm sure half of you could just do the assignment right now without that. But now, and I may go a little bit late, feel free to leave if you don't want to stay for all the setup stuff. It's going to be on the video, but just try and be a little bit quiet if you do leave while the lecture is going on. So I'm going to get up into the setup environment file, and I've included links to everything up here. So you're going to have to download SFML on Windows. If you're on Linux or Mac, you can just do this all command line. You don't need to actually download anything. If you do want to, I highly recommend looking over the tutorial, which we will do in a future lecture for SFML, and the documentation is here. Believe it or not, even though AI exists, just sometimes, does anyone know what RTFM stands for? Yeah, read the effing manual, right? So it's just a good idea to do that sometimes. The way I learned C++ the first time is that before writing a single line of C++, I was on a family trip that was super boring, and I just grabbed a C++ book from the library and read it for like 8 hours. And then I still didn't know C++, but at least I knew some stuff, right? So reading the manual sometimes works. Okay, here's the Linux instructions on how to set all this up. I'm not going to show it because it's super easy. Just a quick note is that wherever I have this, don't type that in. That just means that it's a command line instruction. So you have to install GCC and make an SFML on your system. I have created an install script from this. All Linux comes with wget. It's like a web get, so you can get stuff from a URL. So you don't even need to like download it. I will have a script on my website somewhere. This URL will be an actual URL when you get this file. So you'll just type wget and you get that. Then it won't be executable by default, so you'll just chmod +x that script so that you'll know you can execute it, and then you have to run that script as root. And what that will do is it will install all the libraries. So the reason that this is a little bit complicated is because the Linux library distro doesn't have SFML3 yet. If you just type in like sudo apt install libsfmldev, it'll give you 2.6.1 and none of the assignments will work. So if you have done that, please remove it. Sudo apt remove libdebsml or libsfmldev, whichever one it is, and run this. This will actually pull the most recent version, actually exactly 3.0.1 from their GitHub, and it will compile it from source and install it, and then the makefile should just work. So you run this, it might take a couple of minutes depending on your internet speed, but by the time it's done, SFML should be installed. Please tell me if it doesn't work for you, but I've tested it on 2 different distros and it works. But it does assume you have apt. So it's like an Ubuntu-based distro, Debian-based distro. Then you download and install the zip file, extract it to some directory, maybe A1, navigate to the assignment root directory, and then just compile it by typing make. Make looks at the make file, compiles it all. This will place the executable called SFML game in the bin directory. You can then change directory to the bin directory and run SFML game. So it will be an executable that you can then run. That all becomes a bit cumbersome. So if you look over here at the makefile, the run target will actually make the output, then cd into the bin directory and run the output file. So it'll make, compile and run it for you. To remove all intermediate build files, type make clean. This is necessary sometimes if header files were changed but other files weren't. That's not relevant for assignment 1. But if you're sure that something is right and it's not, just type in make clean before you type make. If you decide to use Clang instead of G++, it should probably work. You just need to change that in the make file. So I highly recommend using G++, which is a GNU C++ compiler. That's it. That's for Linux. You should just be able to install it and run it, and it should work. On Mac, it's slightly more complicated. First, you need to install the Xcode build tools. Even if you don't use Xcode itself as an IDE, you still need to install the Xcode build tools. Then you're going to need to install Brew. If you use a Mac and you don't have Brew installed, I don't know how you get along, but the instructions for installing that, there's a single line that you copy and paste from the Brew website. Then, if you already have Brew installed, be sure to upgrade it so that you get the newest version of SFML. So before you do anything, Brew upgrade, and that should pull all the newest versions of the libraries. Then in order to get SFML, you Brew install SFML. I checked last night. I hope it doesn't change anymore, but that is 3.0.1. That's the version we're using. And then you're going to need to do one extra step, which is to change the makefile if your installation directory is different than the default. So if you type brew info SFML, so if I come over here, hopefully this doesn't break. Live demo. Yeah. Okay, clear. Brew info SFML. Takes a second, and then somewhere, where does it say where it's installed? Right here. Opt homebrew seller SFML 3.0.1. You can see that right here on this line. That's the line you need to get. And then you need to come over here to, let me close this, don't save. So much stuff open. You come over here to the makefile, and in the part for the Mac, you just change this. So if that is different for you, change it there. That's it. And that's how the Mac knows where, the Mac makefile knows where SFML is. Okay. So you copy that into the makefile, and then you go back up to the Linux instructions starting at step 1, and it's all the same for all the command line stuff. And you can literally do this with Notepad, text editor, Vim, doesn't matter. Any text editor you want to use is completely up to you. I'm just showing you VS Code because it's the thing that I find is the nicest. All right, so that's the Mac instructions. And the Windows instructions are a little bit more complicated, obviously, because it's Windows. Why wouldn't it be? The big thing for Windows is that you have to install Visual Studio. Again, not Visual Studio Code or VS Code, but Visual Studio. Visual Studio Community Edition 2022, that's what I have. It's free. The only caveat is that you may have to have a Microsoft account, and it may tell you to sign into the Microsoft account before you can actually use it. When you go to install that, you just need to click one other box, which is ensure desktop development with C++ is selected during the installation. That gives you the compiler, the MSVC C++ compiler that it will be using. Close Visual Studio after you have installed it, because we're about to change some Windows settings that get read at the startup of Visual Studio. So close it again. Download the latest version of SFML. This is a direct link to the version I want you to use. It's on the website, but you can just copy and paste this if you want. It is a 64-bit version of SFML 3.0.1 for this compiler. So that's what you download. Extract this to a folder on your computer with no spaces in it. No spaces is just a Windows environment variable thing, which is super annoying. I have a folder on my computer called cdev. All the programming I do, I have cdev code, cdev library, cdev program, cdev languages. And so I just put this into cdev libraries SFML 3.0.1. So that's where I have put this folder. And make sure that you don't have this scenario where you've actually accidentally unzipped it into another folder with the same name. I've seen this happen a couple of times. Make sure that like the lib and include folders are in that top level folder, not a second folder with the same name. Then what we're going to have to do is you need to tell Visual Studio somehow where the library files are. And the way that I've chosen to do that is I have a variable inside the project file which reads from your Windows environment variables. And so that variable is going to be wherever you install these libraries. And so what you do is you click the Start menu, you type env, and let me just go over here. I think I can just show this. So this is Windows. I hit the Start menu. I type env. That brings up the system environment variables. I know this is an ungodly small resolution here, but what I have done is you click New, and then you type in a variable name and you give it a value. I've already done it here. So this is SFML_dir in all caps, and you just paste, you type in the name of the directory where it is. What we're about to see is there's one other thing that you have to do, which is the path directory, and you have to type in that path again, but /bin. So 3.0.1/bin. That tells Windows where the DLL files are so we can actually run your program. So that's the next step, which I haven't shown yet. Okay, so that's it. Those are the two environment variables that you need to set. And after you've done that, if Visual Studio is open, you need to go back and reopen it because it reads all of those variables in at launch. It won't work if it has spaces in it, unfortunately. Then you modify the path variable. The path variable can read from the variable that you just set up. So it can read that folder name and then you just type /bin after it. But I have noticed for some reasons on some machines that doesn't work. And so I recommend just typing in the full name of the bin directory if that doesn't work. Then download the assignment zip file, and I can show you the rest of this here. So you download the assignment zip file. Let me minimize this. So over here, I have the assignment zip file on my desktop. Okay, here we go. I've got the Visual Studio folder here. So I double click that, and then I just double click sfmlgame.slm. Don't double click the VCX project file, that won't open. Double click the solution file. If everything has gone well up until this point, you open, that opens up Visual Studio. And then over here you have, by default, this is going to say debug. There's a debug build mode and a release build mode. Debug is amazing. You can set breakpoints and inspect variables as it's going and all sorts of stuff. It's great, but it runs about 500 times slower than the release mode. So unless you are debugging, I recommend selecting release. Then what you can do over here on the SFML game, let me just zoom in, you can right click and rebuild or build. So rebuild is the same as make clean. And then down here on the bottom, it is compiling everything. And okay, so down here you'll see if everything is correct, it will say build 1 succeeded, 0 failed on the bottom there. If there was a typo or something, let me just do this and see what happens. If I click build, you'll have some errors down here. Okay, error unknown whatever, right? So that's like the terminal where you get your error messages down there. Also, another way that you can compile and run in a single click is just by clicking local Windows debugger. And you click local Windows debugger, and if you have an error, this will pop up. And it'll say, there were build errors. Would you like to continue and run the last successful build? For the love of everything that is holy in the universe, click do not ever show this again, and click no. Because I've had students running the last version of their build for like a week without knowing that stuff just wasn't being recompiled. And I don't know why that comes up by default. But anyway, fix the error, click it again, and then if everything works, it should just be running right here. Okay? So that's the exact same thing as the other operating systems, but because of the weird way Mac interacts with the VM, the window is so tiny I could never show you anything here, right? So that's why I'm showing you everything in the Mac. So let's go back. We've done all this, done all this. Okay, if common Windows errors, if the first line of the output or any line in the output says that it couldn't find graphics.hpp, then you didn't set the environment variable for SFML correctly, or you've got a typo in the directory name. And if it pops up, if it compiles correctly, tries to run, and then the box says there's a DLL missing, that means you didn't set the path correctly, so it doesn't know where that is. I hope that's it, because I've been talking forever. Actually, it made it in time. That's cool. So just keep in mind, I'll get to your question in a second, that it should work in Linux. Please let me know, like tomorrow or over the weekend, if you tried that Linux install script and it didn't work, because I've got to debug that like immediately to give you enough time with it. But it should work in any of the operating systems.